Welcome! This explainer is brought to you by Forge College. Today, we're going to put on our detective hats and solve a really common mystery. How do you turn a pile of buggy code into a solid, validated program? We're diving into the world of testing, debugging, and integration. Let's get started. So, picture this. You've just finished the last lesson, you've written out all your core functions, the logic feels perfect, every line seems to make sense, you're feeling pretty good about yourself. You've done the hard work, and in a perfect world, that should be it, right?
And then, you run the tests. And boom, your terminal just explodes in a sea of red text. Assertion failed. Panic. It's that sinking feeling, isn't it? That incredibly frustrating gap between the code you thought you wrote and the code that's actually running. Well, that is the mystery we're here to solve today.
But listen, don't think of this as a chore. Not at all. Think of it as an investigation. We're not just programmers today. We are bug detectives. So it's time to grab our magnifying glasses and solve the case of the failing tests.
So what's the very first thing any great detective does when they get to a crime scene? They secure the area and they gather clues. You can't just jump to conclusions, right? You got to collect all the evidence you can before you even start to form a theory.
And here is our investigation toolkit. First up, cargo test --nocapture. This little command is huge. It tells the test runner, hey, show me everything. Don't hide any of the output from my print statements. Then, our second tool, RUST BACKTRACE = 1. This is for when things go really, really wrong. If your program panics, this gives you the full story, a step-by-step trail of breadcrumbs showing you exactly how it got to the scene of the crime. Okay, so we've got our clues. Now it's time for phase 2, interrogation. We need to bring in our main suspect, the code itself. And, well, we need to make our functions talk. And how do we do that?
Our main interrogation technique is the good old printland macro. Or, even better, its cousin, debug-dg. If you sprinkle these inside your functions, you can basically force them to reveal their inner thoughts. You get to see the exact values of your variables at any given moment. It's like a truth serum for your code.
Now here's a pro tip from the field. When you have a screen full of red error messages, it can be super overwhelming. So don't try to solve every mystery at once. Pick one. Isolate a single suspect by running cargo test with the name of just one of the failing tests. This lets you focus your investigation without all that extra noise.
And now, we get to the best part of any detective story, the big reveal. That amazing, super satisfying aha moment when all the clues just click into place and you finally get to unmask the culprit behind the bug.
And here we have a classic offender, integer division. I mean, we've all been there. Look at the buggy code on the left. 5 divided by 100. In our heads, that's 0.05, of course. But in the world of unsigned integers, there are no decimals. The computer sees the 0 and just throws the rest away. So your rate becomes 0. The fix on the right is surprisingly simple. Just multiply first. By calculating stake times 5 before you divide, you keep that precious precision, and you actually get the correct result.
All right, so we've cracked the case of the unit tests. But now we're moving into let's say, a tougher neighborhood. Integration failures. This is where all your different pieces of code have to start playing nicely together. And believe me, this place has its own rogues gallery of usual suspects.
You know, when you're working with Solana programs, your investigation is usually going to lead you to one of two main culprits. First, we've got data layout bugs. These are all about serialization, how we pack data up and unpack it to store it on the blockchain. And second, you've got processor logic bugs. These are the tricky ones, like you're passing accounts in the wrong order, or you're failing an ownership check somewhere.
You can think of this table as your detective's field guide. It really helps you interpret the clues. So if your reward calculation test is failing, you're probably dealing with that integer truncation bug we just talked about. If a state serialized round trip test is failing, odds are your data fields are in the wrong order or maybe the wrong size. And if a big integration transfer flow test fails, that points to a bigger problem, probably with account ordering or a subtle deserialization issue.
But remember this, a detective's job isn't over when they catch the bad guy. The case isn't truly closed until the paperwork is filed. And for us programmers, that paperwork is our debug report.
So what is a debug report? Well, it's a short, professional document that lays out the problem, how you fixed it, and any risks that might still be hanging around. This isn't just for you. It turns your debugging session into something reproducible that your whole team, and trust me, your future self will thank you for.
And a really good case file has a clear structure. You start with the issue. Then, the most important part, the reproduction steps. Third, what was the root cause you found? Fourth is the fix. Show the actual code you changed. Fifth, verification. How do you prove the fix actually works? And finally, you note any leftover risk. A report with these 6 parts is just airtight.
So let's recap the bug detective's code. Number 1, always reproduce failures exactly. Number 2, it's always better to find a real, deterministic fix than it is to just make your tests easier to pass. 3, remember our 2 prime suspects in integration, data layout bugs and processor logic bugs. And finally, always document your work.
And with that, case closed. Your test suite is a beautiful, beautiful wall of green. Your debug report is filed. Your code isn't just written anymore. It's validated, it's robust, and it's ready for whatever comes next. Fantastic work, detective.
So think about it. You've hunted down failures, you've uncovered the root causes, and you implemented the fixes. You've actually proven your code does what it's supposed to do. With all these validated parts ready to go, there's really only one question left, isn't there? Are you ready to put it all together and build your final program for Solana?
If you want to review this topic or learn a ton more about building for Web3, just head over to forge.college. This explainer was brought to you by Forge College. Thanks for joining the investigation.